Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Thabo Mboweni. This lesson is brought to you by the Free State Department of Education in collaboration with Pakama Research and Development. You may interact with us on the WhatsApp number 079 578 2908. Today's lesson is on paper 2, examination preparation for the upcoming exam that you are going to write on Monday. We want to look at the structure of the examination. As I said, the focus is on paper 2. We look at the structure of our paper 2. We see that the paper is going to be divided into two sections, section A and section B. Section A is the multiple choice, 10 of them, which cover the entire syllabus with a total of 20 marks. And then we have the section B, which is the structured questions, and they add up to 130 marks. Now, we remind you again that when you answer your multiple choice questions, do not leave any spaces. You fill all the spaces, all the questions need to be marked, as well as answering these longer questions. Now, let's look at the content that will be covered in your paper 2. We have the chemical change. This chemical change covers most of the marks, which is 92. And then we have your matter and materials, which is allocated only 58 marks. So when preparing for your examination, make sure that more time is allocated to your chemical change, since it's allocated more of the marks. Now, under the matter and material, we are going to look at the organic molecules. We are going to look at the naming, the physical properties, and the organic reactions. That's what we are going to look at under the matter and materials. Let's look at the scope of our paper. We have the rates of reactions. We have the chemical equilibrium. From grade 11, we have acids and bases, redox reactions that we have learned there. All of these topics, they are going to be in your examination. If we look at them in total, we are going to look at organic molecules, and we're going to focus on the homologous series, the IUPAC naming, the physical properties, and the organic reactions. We are going to focus on all of that today, and we want to highlight to you that the scope of the exam extends to the rates of reactions, chemical equilibrium, and redox reactions. Some of these topics we might not be able to cover them today due to time constraints. Now, let's look at your multiple choice questions. Now, in the multiple choice questions, we are going to see that all topics are examinable there. We are going to get all topics, multiple choice questions being asked there. Each question will be allocated 2 marks, and then we are going to pay special consideration when given these questions. We try to identify which topic does the question assess before we attempt to answer, and then we can go about choosing the correct answer by looking at collecting all the facts. Now, before we answer, we need to thoroughly analyze the questions before attempting to choose the options. We remind you that there will be 4 options that will be given. 2 of them are distractors, and 2 of those options are very close to the correct answer. And then you start by eliminating the distractors. You'll be left with 2 options from which you can choose the best answer. Now, we have talked about minimizing the distractors, and then we also have talked about not skipping any question. All questions on the question paper, they need to be answered. Now, let's look at our functional groups. These are the functional groups that you've already learned. We are just reminding you. We have the group of homologous series, which are the alkanes, with the functional group. The structure of the functional group is indicated there, and the name of the functional group there is the carbon-carbon single bond. It is very important to remember that. We do have another homologous series that was studied as well, which is a group of alkenes. And how do we see the alkenes? The functional group here, we are going to see the alkenes with the carbon-carbon double bond. And the name of the functional group here is given here as carbon-carbon double bond. It is also important to note that these alkanes, they are saturated. This term you're going to come across a number of times, which is very, very important when you go to your organic reactions. But when we look at our alkenes, it is also important to note that the alkenes are unsaturated. We are going to talk about that as we continue with our lesson. Let's continue with the homologous series. We have talked about the alkenes with the carbon-carbon single bond. You've talked about the alkanes with the carbon-carbon single bonds, the alkenes with the carbon-carbon double bond, and now we're going to the alkynes with the carbon-carbon triple bond. So whenever we see the alkynes, we know that they have a carbon-carbon triple bond. And then we can go now to the haloalkanes. So this is where we get one atom or two atoms of the halogens from the group 7 elements that is bonded to our organic molecules. And this group of molecules are referred to as the haloalkanes. And then we go to the alcohols. The alcohols there, we are going to identify the hydroxyl group. So when we see the hydroxyl group, we know that this group of organic molecules, they belong to the homologous series, which is the alcohols. Let's carry on. We continue with the homologous series to the aldehydes, and then the structure of the functional group of the aldehydes is indicated there. The name of the functional group is referred to as the formyl group. We go on to the ketones. How are you going to see the ketones? You're going to see this carbonyl group in the middle of the carbon chain, and the name of the functional group is indicated as the carbonyl group bonded to 2 carbon atoms. Now, we carry on to the carboxylic acids. It is very important to see the difference between these functional groups. We see the name of the functional group here is referred to as the carboxyl group. And lastly, we go to the esters. And the structure of the functional group is indicated there. The name, however, is not indicated. Now, we now go into organic naming, the IUPAC naming, the naming of organic molecules. We want to remind you of naming of these molecules as you have studied throughout the year. The first thing that we want to do when we name organic molecules is to identify the functional group of each homologous series. And then we need to know the name ending, the suffix, the name ending. You might want to recall that the ANE is for the alkanes. This is the name ending for the alkanes. The alkanes, they end with the ANE. And then we have the ENE, that is the name ending of the alkenes. Then we have the INE, that is the name ending of the alkynes. Then we have OL for the alcohols. The alcohols, they have a name ending OL. Then we have AL for the aldehydes. Aldehydes, they have the name ending AL. Then we have the ONE, that is the ketones. The ketones, they have a name ending 1. And then the noic acid, that would be the carboxylic acid, So it is very, very important for us to remember all these name endings as we are going to learn how to name or revise how to name the organic molecules. Now, after that, it is very important now that you start noting the longest chain. The longest chain is very important in giving us the parent chain. And then using the functional group, we can also identify the substituents or the branches after we have numbered the carbons on the longest chain. And then we also want to remind you of the hyphen between the number and the letter. There is a hyphen, which you normally call the dash. We normally put the hyphen between a number and a letter. For example, if we want to write 2-methyl, we are going to write 2, then the hyphen, then we write the methyl. It is very important to remember that. And then we use a comma between two numbers. Let's say we have an organic structure with the two methyl groups. Then we are going to say 2, 2. It's a comma because it's between two numbers. Then a hyphen. Then it's going to be dimethyl. So it's very important that we remember that. We leave no blank space between the alphabets. So if we have the 2-methyl butane, so after the methyl, we just write the butane without leaving the space in between. So this is just an example. We are just giving an example of naming where you do not put a space between the letters. So all rules of naming are provided on your examination guideline 2021. The examination guideline that we are using is the examination guideline 2021. We are going to name all these organic molecules practically as we proceed with our lesson. Let's look at the multiple choice questions that you might want to come across in the exam. And we are going to assist in answering these questions, removing the distractors and coming up with the best answer. The question here says, which one of the following is the general formula of alkanes? Now, this tells us that you need to know the general formulas of all the homologous series. The general formula of all the homologous series needs to be known. Now, if we look at the option D, we see that there is a hydroxyl group there. And we know that alkanes do not have the hydroxyl group, so that we can take out. And then we see in option B that the general formula is CnH2n minus 2. So that is the general formula for the alkynes. You need to know all these general formulas. And then we have in A here the general formula for the alkenes. And therefore, the general formula for the alkanes will be option C, that is CnH2n plus 2. So in that way, we are revising the general formulas of the organic molecules. You need to go back and revise all of them. Let's carry on. Now, consider the following statement regarding the compounds with the same homologous series. So we have the compounds with the same homologous series here. And for you to be able to answer this question correctly, it means that you need to know how to define the term homologous series. If the definition of the term homologous series is length, then you will be able to answer this question correctly. However, let's look at the options. We have Roman figure 1 here says that they have the same boiling point. Now, we might want to recall that for compounds who have the same boiling points, then the strength of the intermolecular forces in those substances need to be comparable. In other words, they need to be somehow equal. Therefore, the question says, which of the following statements regarding compounds in the same homologous series? The first Roman figure says they have the same boiling point. That is not true, because this would imply that methane, ethane, and propane should have the same boiling point, which is not true. Methane, ethane, and propane, they are of the same homologous series, yet they do not have the same boiling point. So Roman figure 1 is not acceptable. It is not true. Roman figure 2, they have the same functional group. Now, if we look at the group of alkanes, we can agree that the group of alkanes will have the same functional group. Therefore, Roman figure 2 is acceptable. We can take that as true. Then we also go and check Roman figure 3, which says that they have the same molecular formula. Now, if you think of that example which we gave earlier of methane, ethane, and propane, methane, ethane, and propane cannot have the same molecular formula. So this cannot be acceptable. Therefore, we can go now and look at our options A, B, C, and D and see which one is true according to the question. And then we are going to end up seeing that the only option that is true is A. So that is how we go about answering these multiple choice questions. A lot of theory needs to be studied before we can attempt to answer these questions. Now, the next question says, which one of the following compounds is an aldehyde? Now, we have looked at the homologous series and the structure of the functional groups and the name endings. And we do know that the aldehydes, they have the name ending AL. So we check in the options that are given, which one of them will have the name ending that is a AL. We look at D. This one does not have the name ending AL. And then we might want to remember that this must be an ester, and C must be a ketone, and then B must be an alcohol, and therefore the only aldehyde here will be A. So it is very important to look at the name endings and be able to predict the homologous series and the functional group. We carry on with these multiple choice questions. Which one of the following pairs of compounds are functional isomers? Now, before you can determine which ones are functional isomers, you should be able to define a functional isomer as per examination guideline 2021. You should be in a position to understand that functional isomers will have the same molecular formula. To have the same molecular formula means that the number of carbons and the number of hydrogens must be equal. And then the only difference with the functional isomers is that their functional groups are not the same. Now, let's look at the first option. We have methanol and we have methanol. If we draw the structure of methanol, we expect the hydroxyl group there. And remember, each carbon must have 4 bonds. So that would be the structure of methanol. But if we draw the structure of methanol, remember that methanol should be belonging to the aldehydes, and therefore the functional group there must be the formyl group. Now, if I write out the molecular formula of methanol, I'm going to have CH3OH. And then for the second one, that is methanol, I'm going to have CH2O. So if we look at them, these molecular formulas are not the same. So the other one has 4 hydrogens and the other one has 2. Therefore, the two substances there or compounds cannot be functional isomers. Now, we can also look at them without drawing them. If we look at butane and 2-methylpropane, those substances, they are isomers, yet they are not functional isomers. So if we look at butane, butane will have 4 carbons. Butane has 4 carbons, and 2-methylpropane also has 4 carbons, and the number of hydrogens will also be equal, but they are not functional isomers. They are only chain isomers. So it is very important to identify that these are chain isomers. And then if we look at option C, we see propan 1-ol and propan 2-ol. We can easily see that these two are positional isomers. These are positional isomers. And therefore, we are left with propanoic acid with 3 carbons and methyl ethanoate with also 3 carbons. And then if we draw the structure of both of them, we are going to see that these two are functional isomers. Esterification, let's look at the structure that is given there and answer the question, which says, which one of the following pairs of reactants can be used to prepare this compound in the laboratory? Now, if we look at the part of the structure on the left, and then we look at the ending here, we should be able to see that this part of the structure is coming from the alcohol. This part of the structure is coming from the alcohol, and then this other part, because it is the carbonyl group, it should be coming from the carboxyl acid. So this one is coming from the carboxyl acid. Therefore, if the left side is coming from the alcohol, we can tell the name of the alcohol with counting the number of carbons. How many carbons? The carbons are 1, 2, 3. Therefore, the alcohol must have been propanol or propan-1-ol. You can say propanol or propan-1-ol. So the name of the alcohol there was propan-1-ol. And then now we can look at this part that is coming from the acid. How many carbons does it have? It has 2 carbons. Therefore, it must have been ethanoic acid. That must have been ethanoic acid. So any structure of an ester can tell us which alcohol and which acid have been used in order to prepare for that ester. So now let's go on to see the options that are given in order to choose the correct answer. The first option says propanoic acid and ethanol were used. It cannot be correct because we see the right-hand side that indicates the part that comes from the acid that it has only 2 carbons. So this must be eliminated. Propanoic acid again, eliminated. We are left with C and D. And C says ethanoic acid and propan-1-ol. This is the correct option as we have tested before. But methanoic acid and propan-1-ol cannot be correct because the right-hand side of our structure has the number of carbons, which is 2. So that is how we go about answering these multiple choice questions. Let's go and look at the multiple choice question that has to do with naming. Consider the following structure. Which one of the following is the IUPAC name? So here we're looking at the IUPAC name. Remember, when we look at the IUPAC name, we have to start by identifying the longest chain. And remember that our longest chain has to include the carbon that carries the functional group. So by looking at this structure, we see that this part of the structure is our functional group. It carries the functional group, and therefore we can look for the longest chain from that carbon. Now, if we start counting, we can see that the number of carbons would be 1, 2, 3. That is the first chain. 1, 2, 3. The second one, 1, 2, 3, 4. So our longest chain here, we are getting 4 if I connect a line there without lifting a pen. So I'll see that my longest chain includes those carbons that are highlighted there. And then the other carbons that are not highlighted on the line, the ones which are circled here, these carbons will be our branches or our substituents. Now, when the second step, remember the first step, we have identified the longest chain. The second step, we are going to number our carbons. And when numbering our carbons, we need to make sure that we start where the functional group is closest. So the functional group cannot be further. The functional group needs to be closest. So now, if I want to take this carbon as the first carbon, that would be 1, 2, 3, 4. I see now that the carbon with the functional group will be in the 4th position. So that is not acceptable. The carbon with the functional group cannot be furthest. Therefore, I have to take the first carbon to be the one where the functional group is included. So this must be the first carbon, second carbon, third carbon, or fourth carbon. So one learner can put their fourth carbon on the left. I choose to put my fourth carbon on the right. Now, remember that we have indicated that these carbons which are not on the longest chain or on the parent chain, they are the branches. Now, we want to attempt to name this compound before checking the options that are there. Now, the functional group, which we have talked about, we've indicated that this is a functional group, will determine our name ending. And by looking at it, we can see that this is an acid. So the name ending must have enoic acid. The name ending will have enoic acid. Then we go now and check the parent chain, the longest chain. How many carbons does it have? 1, 2, 3, 4. So if it has 4 carbons, then it must be a bute. But when you write the name, you cannot just write bute. You have to write buta I'm going to erase this so that I can write it out nicely. So the name here must be butan. You don't write but only. Then we end with the noic acid. But now this is only the suffix. This is only the suffix. We still need to include these carbons that are the branches, which are not included there. And these carbons that are not on the parent chain, we refer to them as the substituents or the branches, and they form part of the prefix. Now, we need to indicate their name. If you look at the CH3 as a branch, is referred to as the methyl. And then we also have the CH3, CH2, which is referred to as the ethyl when it is a branch. So now we have the methyl groups here. The methyl groups are in which positions? Remember, this is the first carbon, second, the third, and the fourth. So we have two methyl groups in the second position. So this is going to be 2. Remember, between a number and a number, we put a comma. So 2, 2. And there's a third methyl group, but this one is not in the second position, but it is in the third position. So it's going to be 2, 2 for this one and that one. For the third one, because it's in position 3, we are going to say comma 3. And that includes now the third branch. Now, after indicating their positions, we need to indicate their name. But remember now, we were writing numbers. We now want to write a letter. And the symbol that we put between a number and a letter is a hyphen, which you normally call a dash. So it's going to be 2, 2, 3, then a hyphen. How many numbers did we include there? How many are these branches? There are 3. So for 3, we're going to say try. And the name of the branch there must be a what? A methyl. So be careful that when you write a letter and a letter, we do not put a comma or a hyphen. So the name of this molecule, as we have named, will be 2, 2, 3 trimethyl butanoic acid. So let's see if there's a name that is similar to that. If we start with D, D would say 1, 1, 2, 2 tetramethyl propanoic acid. That is not the same as our name. C says 2, 2, 3, that is not the same. B says 2, 3, not the same. Only A says 2, 2, 3 trimethyl butanoic acid. So the best answer in this regard would be option A. Now let's go to the long questions in the nomenclature. This is a type of questions that you might expect on Monday as you write your examination. Now, let's go straight into it. Consider the letters A to F in the table below. These letters A to F, they represent 6 organic compounds. Now, you will see that in the table that is given there, some molecules such as A, B, and F, they are not drawn as structures, while we have C, D, and E, which are given as structures. The molecules that are given as structures, usually the examiner will want to ask you to name them. Yet the molecules that are given as names and condensed structural formula, the examiner might want to ask you to draw them as to indicate. So any molecule that is given as a name or condensed structure in your examination, you might want to draw that molecule so that you can actually see what is happening in that molecule. Now, if we look at this table here, we also need to be able to see the functional groups of each compound that is given here. But we will go straight into the questions as we don't want to run in short of time. Is compound A, they are asking about compound A now. Is compound A saturated or unsaturated hydrocarbon? So sometimes we might not be able to tell whether it's saturated or unsaturated without drawing it. If we can quickly draw it, we would see that we initially have a CH3, and then it's followed by a CH2, and then it's followed by another CH2, and lastly, we have a CH3. Now, if you observe carefully here, you will see that there are only single bonds between the carbon atoms. And therefore, we can easily answer this question to say that compound A is saturated. And what will be the reason for that? There are only single bonds between the carbon atoms. In other words, we can say that there are no multiple bonds between the carbon atoms. So we have answered 2.1. We go straight now to 2.2. 2.2 says, write down the letter or letters that represents each of the following. So in 2.2.1, we're looking for a ketone. We look at the structures that are given there. We want to see a ketone. And what do we know about a ketone? The ketone has a carbonyl group in between the carbon atoms. So which one is that? The letter that represents the ketone is supposed to be E. Then we also look for a letter that represents a haloalkane. A haloalkane must have 1, 2, or more halogens in that molecule. 1 or 2 or more halogens. If we look at compound D, there is bromine there. There is another bromine there. So compound D must be an example of haloalkane. And 2.2.3 now says the two functional isomers. We want to look for two functional isomers. I want to erase here so that we can look clearly. Remember, we were looking at the functional isomers earlier. The functional isomers should have the same number of carbons, same number of hydrogens. That is the same molecular formula, but they must only have different functional groups. So let's look at the structure here. We have a structure in E. This structure has how many carbons? 1, 2, 3, 4. And then that is 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. It is 8 hydrogens. And then it is 1 oxygen. But let's look at butanol. Butanol, remember, we indicated that if the examiner gives you a name, the examiner expects you to be able to draw that molecule. So for us to draw butanol, we look at the name ending, and we must be able to see that this is an aldehyde. From the name ending, we must be able to see that this is an aldehyde. The aldehyde will have the formyl group at the end, and the but tells us that there must be 4 carbons. How many carbons are there? 1, 2, 3. Then I put the 4th one. Then the rest now will be the hydrogens. Now I can put the hydrogens in the carbons so that each carbon has 4 bonds. Each carbon must have 4 bonds. Then we count in the structure of butanol. How many carbons are there? We have 4 carbons. Number of hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. And how many oxygens? Only 1. The molecular formula are the same. Are the functional groups the same? The functional groups are not the same. Therefore, these 2 compounds, they are functional isomers. So the functional isomers here is B and E. Okay, we carry on with our question. We're now considering compound C. We want to consider compound C. Where is compound C? Here is our compound C. The question says consider compound C. Now, 2.3.1 says, is compound C a primary, secondary, or tertiary alcohol? Now, for us to be able to answer this question, we need to be able to define what is a primary alcohol, what is a secondary alcohol, and what is a tertiary alcohol. We need to remember that the primary alcohol, the carbon that is bonded to the hydroxyl group is bonded to one other carbon. And for secondary alcohols, the carbon that is bonded to the hydroxyl group is also bonded to 2 other carbons. And for the tertiary alcohols, the carbon that is bonded to the hydroxyl group is also bonded to 3 other carbons. So let's look at this one. This is the carbon that is bonded to the hydroxyl. How many other carbons is it bonded to? This carbon is only bonded to 1 other carbon. Therefore, this must be a what? A primary alcohol, because the carbon bonded to the hydroxyl group is bonded to one other carbon. So that would be our reason. So the answer would be primary alcohol, and the examiner says give a reason for your answer. The reason would be the carbon bonded to the hydroxyl group is bonded to only one other carbon. Then the last question says in 2.3.2, write down the structural formula and the IUPAC name of the chain isomer. We are looking for the chain isomer of compound C. So this is compound C that we are still talking about. We are looking for the chain isomer. If we look at the longest chain in the compound as it is given, let's look at the longest chain of the compound as it is given, 1, 2, 3, 1, 2, 3. So because the longest chain now as it is given is 3, we can draw another structure of a chain that is longer than 3. So in other words, we can draw 1, 2, 3, and now this carbon that was a branch, we now put it in the longest chain. Then we also put the hydroxyl group. Then that would be the structure of the chain isomer of compound C. But the question is looking for the structure and also the structural formula and the IUPAC name. And the name of this molecule will now is now going to be butanol. Sorry. The functional group here is the hydroxyl. Therefore, the name is going to be butanol. Let's look at the typed out answers. Where are they? The typed up answers are omitted. So the name of this molecule will be butanol as we have drawn them. It was 1, 2, 3, 4 with the OH, and the hydrogens are included there, so that each carbon has 4 bonds. Each carbon should have 4 bonds at all times. So number of carbons, 1, 2, 3, 4, and then it is the hydroxyl group there. Therefore, the name will be butanol or butanol. Okay, we go now to the next question. That is 2.4. We have looked at the first part of the questions. We continue with 2.4 and 2.5. And 2.4.1 says the IUPAC name of compound D. We want to name this compound, which is compound D. Remember the rules. We have talked about the rules today, that we need to start by identifying the longest chain. So let's start by identifying the longest chain. If I count the number of carbons here, there will be 1, 2, 3, 4. That is not the longest. 1, 2, 3, 4, 5, 6, 7. So my longest chain has 7 carbons. Now, I want to number these carbons so that the branches come closest. So as I number the carbons so that the branches come closest, this will be my first carbon, the second carbon, third carbon, fourth, fifth, sixth, and 7th carbon. So in the longest chain, there are 7 carbons, but we do realize that this carbon here does not fall into the longest chain. It does not fall into the longest chain. And we also do realize that in these 2 positions here, and the 2 positions there, we have the halogens. So now we want to name this molecule. For the bromine, the subscript will be bromo, and for the CH3, the subscript will be the methyl. Where is the bromo? We have the bromo in position 2 and 3, and we have the methyl in position number 5. Now, when we write our subscript, we need to make sure that the alphabetical order is followed. We have a bromo, we have the methyl. Alphabetically, the bromo is the one that comes first. Therefore, we indicate the positions of the bromo. The first bromo is in position 2. Remember, between a number and a number, we put a comma. So this will be 2, 3. The first one is in position 2. The second one is in position 3. And because there are 2 of them, we do not forget the hyphen. Because there are two of them, we are going to say di. Di means that there are two. So this is going to be 2,3 di bromo, 2,3 dibromo. Then we remember that there was another branch which is a methyl. That methyl is in position 5. So we're going to say 5 methyl. Then we can now go on and name what is in the longest chain. Remember, we need to have no space in between the letters. So the longest chain there was 7. So the 7 is hept. And then because there are single bonds everywhere, then it's going to be heptane. So that is how we can go about answering this type of questions. Okay, let's carry on. So I'm going to erase here so that we can carry on. In 2. Then it says we must name the functional group. We need to name the functional group of compound B. We did draw a functional group of compound B. The whole molecule of compound B was drawn initially. And then we see that the functional group, the structure of the functional group, it appears to be like that. And the structure of the functional group here has a name which is called the formyl group. So the name of the functional group here is the formyl group. The question says, name of the functional group of compound B, and the answer would be formyl group. Now we go to 2.5. A sample of compound F contains these percentages as mass percentages. And then the question would say, if the molar mass is 60 grams per mole, calculate the molecular formula of compound F. So this is testing some of the concepts that were learned in grade 10. So for us to answer this question, we need to assume a 100-gram sample, and therefore that will be interpreted as 40 grams of carbon and 53.3 grams of oxygen. And then if we take the difference now, remember each molecule must have a 100% mass. Therefore, we can take 100% minus those percentages, 100 minus 40 minus 53.3. That would give us 6.7. So we'd have 6.7 grams of hydrogen. If we divide now to get a number of moles, the molar mass of carbon is 12, the molar mass of oxygen is 6, the molar mass of hydrogen is 1, and then so this divided by 1 would be 6.7, and then we can also get for the other ones. Let me just go through the calculator here. So 40 divided by 12, that is 3.33. This is 3.33. And then we also have 53.3 divided by 16. That is also 3.33. 3.33 as well. So we divide with the smallest ratio. The smallest ratio is 3.33. Smallest ratio 3.33. We divide with this ratio across, and then the ratio, the smallest ratio that you're going to get here is 1 is to 1, and then is to 2. So that would mean that our number of carbons is 1, number of oxygen 1, number of hydrogens 2. So this is the molecular formula. If you add up the molecular mass of the molecular formula, you would find that the molecular mass of COH2 would give us 30 grams per mole. And if we divide that, 60 divided by 30, the ratio is going to be 2. So that means to get the molecular formula, we multiply everything by 2. So that would be C2H4O2. So that is the molecular formula. So the question was looking for the molecular formula, and we were able to get that. So if we answer 2.5.2, the question says, write down the IUPAC names of the 2 organic compounds that will have this molecular formula. So how many carbons are there? There are 2 carbons. and there are also two oxygens. So the first one can be ethanoic acid, and the second one would be methyl methanoate as an ester. So let's go through the solutions quickly. We did talk about saturated single bonds, the compound E and D, B and E, and then the primary alcohol, we have talked about them. And then the formyl group, the structure, we have talked about it as well. And then this is the molecular formula, and we were able to get this is the empirical formula. We were able to get the molecular formula as C2H4O2 because our ratio was 2. So we want to go straight now into the physical properties of organic molecules. So when looking at the physical properties of organic molecules, it is very important to know that they depend on the strength of the intermolecular forces. If the strength of the intermolecular forces decrease, now we can tell that we are going to have a lower boiling point, and we are going to have a higher vapor pressure, and we are going to have a lower melting point. If the strength of the intermolecular forces increase, the boiling point is going to be higher, the vapor pressure will be lower, and the melting point is also going to be higher. So by physical properties, the physical properties that we are going to focus in this syllabus is the melting point, boiling point, and vapor pressure. So it is very important that you go through this and see how all of these intermolecular forces affect these three physical properties. Now, we want to know now in terms of their homologous series, which homologous series carries what type of intermolecular forces. So now, all these homologous series, alkanes, alkenes, alkynes, aldehydes, ketones, esters, halogenes, alcohols, and carboxylic acids, they all have London forces. But we do have only this group, alkanes, alkenes, alkynes, which only have the London forces. And then we have the aldehydes, ketones, esters, and haloalkanes, which only have the dipole-dipole forces. And lastly, we have the alcohols and carboxylic acids, which primarily have the hydrogen bonds. Remember, all of them, they have the London forces, but for alkanes, alkenes, and alkynes, it's London forces only. For aldehydes, ketones, and esters, and haloalkanes, the London forces are still there, but the active intermolecular forces are the dipole-dipole forces. Alcohols and carboxylic acids, London forces are there, but the active intermolecular forces are the hydrogen bonds. It is very important to know that because it's going to be used in your explanation. Now, the intermolecular forces depend on the chain length. The longer the chain, the larger the surface area, the stronger the intermolecular forces, and more energy is going to be needed to overcome the intermolecular forces. And if more energy is needed to overcome the intermolecular forces, we expect a higher boiling point. And if the boiling point is higher, the vapor pressure will be lower. Now, if the compounds are of the same homologous series, we check if it is branched or it is straight. If it is branched, we remember we talked about a straight one. We said a straight one has a longer chain length, larger surface area, stronger intermolecular forces, more energy needed to overcome the intermolecular forces, higher boiling point, lower vapor pressure, and higher melting point. If it is branched, then we know that the surface area is smaller, the intermolecular forces are weaker, less energy is needed to overcome the intermolecular forces, the vapor pressure is going to be higher, the boiling point is going to be lower, and the melting point is also going to be lower. When explaining the physical properties, it is important to follow these steps. In step number 1, you state the difference in the structure. So in other words, you are going to state the type of intermolecular forces that are there in the two molecules. For example, let's say you have methanol and then you have methane. In the first step, you're going to say that methanol has hydrogen bonds while methane has London forces. That is your step 1. And then in your step 2, you state the effect of this factor on the intermolecular forces. Because you have stated that methanol has hydrogen bonds and methane has London forces, you now go on to say that hydrogen bonds are stronger than the London forces. And then in step 3, now you talk about the energy. Now, since you have said that hydrogen bonds are stronger than the London forces, you are now going to say that more energy will be required to overcome the hydrogen bonds as compared to the London forces. Then you're going to conclude and say methanol will have a higher boiling point. Now, let's go through the questions, multiple choice questions relating to the intermolecular forces. Which one of the following compounds will have the lowest boiling point? Remember, the lowest boiling point is associated with the weaker strength of the intermolecular forces. We have molecular forces which are referred to as the London forces. We have the dipole forces, and we have the hydrogen bonds. Now, we know that the hydrogen bonds are stronger than the dipole forces, and the dipole forces are stronger than the London forces. Now, let's look at them. Butane. Butane comes from the homologous series alkanes, and therefore the intermolecular forces that must be there must be the London forces. And then butanol is an aldehyde, so we expect dipole forces there. And then we have butanol, where we expect the hydrogen bonds. And then we have methyl propane, where we expect the dipole forces. So here is the dipole forces. Remember the strength, hydrogen bonds are the strongest, followed by the dipole, and the weakest ones are the London forces. The stronger the strength of the intermolecular forces, the higher the boiling point. The weaker the strength of the intermolecular forces, the lower the boiling point. Which intermolecular forces are the weakest here? The London forces. The London forces are the weakest. If the London forces are the weakest, less energy will be required to overcome the intermolecular forces, and therefore butane will have the lowest boiling point. Now let's go to the structured questions which relate to the topic that we are in, the physical properties of organic compounds. Let us investigate the melting points and boiling points of the 4 organic compounds as shown in the table below. 3.1 says, define the term melting point. Remember, for all your definitions, we refer to the examination guideline 2021, and you are going to see in the examination guideline 2021 that melting point, when it is defined, remember, you should not say a point. It's supposed to be a temperature at which the solid, that is this, I just want to type the solid here. Let me erase the solid phase. The solid will be at equilibrium with the liquid phase. So check the definition from the examination guideline. And remember, it does not start with a point. It is the temperature. You need to check the definition of the examination guideline. 3.2, the melting points of compound A and B are compared. So we are comparing now A and B. Now, 3.2.1 says, write down the independent variable. What is the independent variable? The independent variable is a variable that is being manipulated, or the variable that was changed in the experiment. The variable was changed in the experiment. And if we look at compounds A and B, pentane has a longer chain, and we have 2-methyl butane, which has a spherical chain. So we can easily see that the chain length was changed in the experiment. So we can expect our independent variable to be the chain length or the surface area. Surface area or chain length to be the independent variable. So 3.2.2 says, explain the trend in melting point. So we want to explain the trend in melting points. So let's look at them. Melting points, explain the trend in the melting points. We look at the melting points, they start from negative 130, they go on to negative 47. So we can see that the melting points are increasing as we go there. And then what we see in terms of the compounds as we go down, they're becoming more branched. So as we go down there, the compounds are becoming more branched. So when you want to explain the trend in the melting points, we can indicate that as we go down, let's say maybe from compound A to B, the chain length is decreasing. And if the chain length is decreasing, the strength of the intermolecular forces will also decrease. In this case, we must say the strength of the London forces decreases. Less energy will be required to overcome the intermolecular forces, and hence a decrease in the melting points. We are going to see the right out answer in the next slide. The boiling points of compounds A, C, and D are compared. So we are comparing now A, C, and D. So A, it's an alkane, C is an alcohol, and D is a carboxylic acid. Identify the compound with the induced dipole or London forces only, and that will be compound A. Remember, compound A, it belongs to the homologous series, which is alkanes. Write down the structural formula of the functional group of compound D. Compound D, it's a carboxylic acid. So the structural formula of the functional group should be indicated here, which is the hydroxyl group. And then we explain, the other question says, explain the difference in boiling points by referring to the type of intermolecular forces. 3.4 says, which one of the following compounds, D or E, has the highest vapor pressure? D or E, we are looking at D and E, which one having the highest vapor pressure? The one with the highest vapor pressure will be the one with the lowest boiling point between the two compounds. And then if we look at the one with the lowest boiling point here, that would be E. So that would be E. And then refer to the data in the table to explain the answer. So the data in the table indicates that this one has the lowest boiling points between the two compounds, and therefore it will have a higher vapor pressure. Now, I want us to look at the answer to 3.3.3 in the typed up answers. So 3.3.3 says, explain the difference in boiling points by referring to the type of intermolecular forces. So 3.3.3, compound C has one side of hydrogen bond, and compound C has one side of hydrogen bond because it's an alcohol, and compound D, it's a carboxylic acid, and because the carboxylic acid has two sides of hydrogen bonding, so the intermolecular forces in compound A are weaker than the intermolecular forces in compound C. And then we did answer E, and then we did indicate that it has a lower boiling point. Let's carry on now to the organic reactions. When dealing with the question of organic reactions, it is very important now to remember those terms that we've talked about initially: saturated or unsaturated. A saturated organic compound will contain only single bonds between the carbon atoms, and the unsaturated organic compounds will contain multiple bonds between the carbon atoms. Now, we are seeing here that we are going to look at unsaturated organic molecules. If we can look at all of them that are indicated here, they are unsaturated. Unsaturated organic molecules will only undergo addition reaction in your syllabus. So when you see any molecule with a multiple number of bonds within the carbon atoms, you need to know that that molecule should undergo addition reaction. So any unsaturated organic molecule should undergo addition reaction. So let's start with ethene here. Ethene when reacting with chlorine should undergo addition reaction, and the type of addition reaction here should be halogenation. So what are the reaction conditions here? We need an unreactive solvent, and the product here will be a haloalkane. When the unsaturated organic compound now reacts with the hydrogen halide, then we are going to get the major product where the hydrogen bonds to the carbon that already has most hydrogens. So if we look at the two carbons that are occupying the double bond, the first carbon here has two hydrogens and the carbon in the middle has only one. So the hydrogen should go to the first carbon and the bromine should go to the second carbon for us to get the major product. So in the organic chemistry that we are doing, we focus on the major product. Remember, when adding a hydrogen halide, the hydrogen goes to the carbon that already has most hydrogens. Now, the type of addition reaction here that we are looking at is hydrohalogenation, and the reaction condition is that no water must be present, and then an unreactive solvent is needed as well. Now, the third type of addition reaction that we are going to focus on is when hydrogen is added, and the type of addition reaction where hydrogen is added is going to be called hydrogenation. The catalyst that is needed here is platinum, nickel, or palladium. So hydrogenation is a type of addition. Then we go to the last one, the addition of water to an unsaturated organic compound. That rule again still holds. The hydrogen will go to the carbon that already has more number of hydrogens. Therefore, if you check between the first and second, the first carbon has more hydrogens, therefore should receive the hydrogen, and the second carbon will receive the OH. So for us to get the major product, the hydroxyl will be attached to the carbon in the middle. Now, the catalyst will be needed here, and our catalyst will be sulfuric acid. Whenever we add water, the catalyst, which is sulfuric acid, is always needed. And then for us to undergo this type of addition reaction where water is added, this type of addition reaction is called hydration. And for us to have hydration, excess water is needed as a reaction condition. Let's go into the multiple choice question where hydrolysis is tested. If you go into your examination guideline, you will see that hydrolysis is a chemical reaction of a salt with water. And then the question says, which one of the following is a product? We are looking for the product formed during the hydrolysis of bromoethane. Now, you might want to recall again that hydrolysis is a substitution reaction, and therefore, if it's a substitution reaction, it cannot give us an unsaturated organic compound. So ethene is an unsaturated organic compound, therefore ethene cannot be a product there. And then we are looking for one of the following, which one of the following is a product formed during hydrolysis of bromoethane. So the hydrolysis of bromoethane cannot give us water. The hydrolysis of bromoethane cannot give us bromine, but the hydrolysis of bromoethane can only give us ethanol. So that is the substitution there of this was two carbons with a bromine. So this is bromoethane here. So this is bromoethane. So if bromoethane is treated with a strong base such as sodium hydroxide, that is dilute, then we are going to see here that the hydroxide will come and substitute the bromine, and then we are going to have ethanol. So ethanol is going to be the product, and the other product will be sodium bromide. So that's why we cannot accept bromine, but we can accept sodium bromide as a product. So the only product that is correct here is ethanol. Okay, let's carry on. We are looking now at the elimination reaction. We are going to consider the reaction below where an X compound is treated with concentrated sulfuric acid, and the products that we get here is the CH3, CaCH, and CH3 and water. So now, if you look at this molecule here, if we try to draw it, you must be able to see that this molecule here should be unsaturated. That is a CH and the CH3. Now, if you look at the number of bonds between the carbons in the middle, you will see that there are 3 bonds there. And we know that each carbon is supposed to have 4 bonds. Now, the carbons in the middle are having a multiple bond, and this indicates that this molecule is unsaturated, and this also indicates that this type of reaction is an elimination reaction. So now the question says, which one of the following is correct about reactant X? Reactant X is A, tertiary alcohol. You should know by now, we have talked about the tertiary alcohol, where it is an alcohol where the carbon bonded to the hydroxyl is bonded to 3 other carbons. And a tertiary alcohol should not be straight. It should have branches. Therefore, compound X cannot be a tertiary alcohol. And then a secondary alcohol and a primary haloalkane. This cannot be a primary haloalkane because we do not have any halogen here. So we are left with option B and option C to choose from, whether it was a primary alcohol or it was a secondary alcohol. Now, if we look at the carbons where the hydroxyl and the hydrogen were removed from to form water, so we see that this carbon was affected and that carbon was affected. And if the hydroxyl was in between this carbon and that carbon, it means that carbon was bonded to 2 other carbons. And therefore, the best answer here would be a secondary alcohol, not a primary alcohol. Then we carry on now to organic reactions, long questions. We have a question here that says a saturated hydrocarbon A undergoes cracking to form 2 organic compounds, an alkene and alkene B and alkene B. So this is an alkene and then alkane C. Now, the molar mass is given of these 2 substances, and then we might want to determine how many carbons each one has. So B, we are told it's an alkene, and then C, we are told it's an alkane. So one way of determining the number of carbons that each one has, we can take this molar mass divided by 12. 12 is the molar mass of carbon. So if we divide by 12, we can approximate the number of carbons that are there in that molecule. So if we take 42, divide by 12, we see that this compound should have 3 carbons. The number of carbons in that compound should be 3. And then that is an approximate number. If we take 58, divide by 12, so we approximate the number of carbons here to be 4. So we approximate number of carbons in B to be 3, number of carbons in C to be 4. We also need to remember the general formulas. The general formula for alkenes must be CnH2n. For alkanes must be CnH2n plus 2. Therefore, that will help us to know the number of hydrogens that are there. Okay, the flow diagram shows how compound A can be used to prepare an ester. This question is inappropriate. I think it was incorrectly inserted there. A, B, C, and D represent organic compounds. 1, 2, 3 represent. So this is incorrectly placed. So the first question here is define cracking. Cracking Remember all definitions as per examination guideline 2021. The breaking down of longer alkanes into shorter usable molecules. You will check it on the examination guideline. And then the next question says the IUPAC name of compound B. So let's look at compound B. We did tell that compound B has 3 carbons by dividing by 12. And we also know that it's an alkene. So we want to give a name of an alkene with 3 carbons. So the name of an alkene with 3 carbons, we also have to refer to the flow diagram. We have compound B here. If compound B reacts with HCl, we get 1 chloropropane. So it means now that the name of this molecule, here must be propene or prop 1 in. So that must be prop 1 in, because we know that the carbons are 3 and we also know that it's an alkene. So let's carry on with the other questions. The other questions follow. The structural formula of compound A. For us to get the structural formula of compound A, remember the compound A is the structure that was broken into B and C, but we know that B has 3 carbons and C has 4 carbons, and we also know that A is an alkane. So we can easily draw that structure of A by saying that it will have firstly 3 carbons and the other 4. So there's 1, 2, 3, 4, 5, 6, 7. Then we put the hydrogens here. The name of this molecule will be heptane. Each carbon should have 4 bonds. Each carbon should be having 4 bonds. The bonds should be closer to the carbons there. The type of reaction represented by reaction 1. Let's go and see the type of reaction represented by reaction 1. Reaction 1. Remember, B is unsaturated. And if B is unsaturated, we have indicated that unsaturated organic compounds only undergo addition reaction. Therefore, reaction 1 is supposed to be an addition reaction. So we carry on with other questions. The structural formula of the major product of reaction 1. Let's go and see reaction 1. We want to see reaction 1. The major product of reaction 1. So we can easily get the major product of reaction 1 from the structure that we have drawn. Remember, we have prop 1 in there. Let me just go straight to the solutions. So from prop 1 in, remember that the hydrogen must be attached. Remember the structure here, prop 1 in, propene, in other words, has the following structure. So this is the structure of propene. So let's count number of bonds. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, something was added there. Chlorine gas was added. Chlorine, was it chlorine? Let me just go back. Hydrogen chloride was added. Hydrogen chloride was added. So now, if hydrogen chloride is added, what we need to know is that hydrogen will go to the carbon that already has the most hydrogens, and the chlorine should go to the carbon with the least number of hydrogens. That's why we see the chlorine there in the middle. So this is the chemical reaction that represents the substitution reaction. In 4.2.5, the balanced equation for reaction 2 using condensed structural formula. Let's go back to reaction 2. Reaction 2, we have 1 chloropropane with dilute sodium hydroxide. So we expect a substitution reaction there. So the OH will go now and substitute the chlorine. So if during that substitution reaction, if we can look at the condensed formula here, it is written CH3, CH2, CH2, and the Cl, which was in the first position. And the position of the Cl now is substituted with the OH. And then this sodium here will now bond with the chlorine to form this sodium chloride. So in the last question here, we're looking at the esterification equation where propanol reacts with ethanoic acid and they form propyl ethanoate. The last question is the combustion reaction of butane under excess oxygen to form carbon dioxide and water. We are running short of time. I'm just rushing quickly to go to rates of reactions. Let's look at the rate and extent of chemical reactions. We can look at energy and change, and we will note that there are two types of reactions that we can get there, and that is exothermic reactions and endothermic reactions. The exothermic reactions, they release energy into the surrounding, and the endothermic reactions, they absorb energy from the surrounding. From the graphs that are given, we can tell if a reaction is exothermic, if the energy of the products is less than the energy of the reactants. If the energy of the products is greater than the energy of the reactants, we can tell that the reaction is endothermic. The enthalpy is very important in that regard. If enthalpy is less than 0, we know that the reaction is exothermic. And if enthalpy is greater than 0, we know that the reaction is endothermic. It is also very important to note the activation energy as the minimum energy needed for a reaction to take place, and the activated complex here as the unstable transition state where reactants turn into products. This is grade 11's work, and it needs to be revised as we go into the rates of reactions. In the rates of reactions, we are going to look at the collision theory. If we revise the collision theory, it clearly states the conditions under which any chemical reaction will occur. Now, it clearly states that, firstly, molecules should collide. And these molecules, as they collide, they must collide with a minimum energy that is equal or higher than the activation energy, so that the process of breaking existing bonds can happen. Now, even while they collide with sufficient energy, they also need to be properly orientated. So they must collide with proper or correct orientation so that the effective collision can be resulted. So that is the collision theory summarized. Molecules should collide. They must collide with sufficient energy, and they must be properly orientated. And if all the three factors are there, we have an effective collision. And an effective collision will lead to a chemical reaction occurring. Now, the Maxwell and Boltzmann distribution curve, the effect of increasing temperature on the reaction rate. We need to be able to note that the temperature can be defined as the average kinetic energy of the molecules, and therefore at the higher temperature, the average kinetic energy of the particles increases. So as the temperature increases, the average kinetic energy of the molecules increases, meaning that the molecules will start moving faster. Molecules move faster as the temperature increases. So if the temperature is increased, there will be more molecules that will have sufficient energy or sufficient kinetic energy, and because of that, there will be more effective collisions that take place per unit time, and the rate of reaction will increase. When we look at that on the Maxwell and Boltzmann distribution curve, so we will see that a curve that is a lower peak and the peak that is shifted to the right is the one that represents a graph of a higher temperature. And then if we look at the shaded part, the graph of T1 has a smaller shaded part, and the graph of T2 has a larger shaded part. The area underneath the graph represents the number of molecules. And then if we look at the area on the right-hand side of the activation energy line, then it means we are looking at the number of molecules with sufficient energy to collide. In other words, we are looking at the number of molecules with energy that is equal or greater than their activation energy. These are the molecules that will lead to effective collisions. For graph of T2, they are greater, and for graph of T1, they are smaller. Therefore, the higher temperature leads to the rate of reaction increasing. The effect of catalyst on the Maxwell and Boltzmann distribution curve. If a catalyst is added, now the catalyst, what does it do? It leads to a path of lower activation energy. The activation energy is lowered when the catalyst is added, and if the activation energy is lowered, then we are going to start having more particles that have sufficient kinetic energy to collide, and then we'll start having more effective collisions that take place per unit time, and the rate of reaction will start increasing. How do you affect the addition of a catalyst on the Maxwell and distribution curve? Now, the first line here, the first line of activation energy, that is the line of activation energy if a catalyst is not there. With an addition of a catalyst, this line is shifted to the left. So this is the activation energy when a catalyst is added. So this is the activation energy line when there is no catalyst. So that is very important as we revise that. So let's look at the activation energy here. The activation energy for a reaction that is catalyzed is indicated here, and the activation energy for the uncatalyzed reaction is also indicated there. You will be able to see that a catalyzed reaction has a lower activation energy, and in that way, the mechanism of the reaction has been changed so that the reaction can proceed faster. Moving quickly, the effect of concentration. Now, you will recall that concentration is number of moles per unit volume. Now, at the higher concentration, there should be more molecules per unit volume. At the higher concentration, there are more molecules per unit volume. And then if there are more molecules per unit volume, we expect more particles to collide at the correct orientation per unit time. And then in that case, the number of effective collisions that takes place per unit time will increase, and the rate of reaction will therefore increase. On the Maxwell and Boltzmann distribution curve, the effect of catalyst will not change the shape of the graph, rather will make the graph bigger or smaller. With the higher concentration, that is the graph of A, the graph of A has a higher concentration compared to the graph of B. Now, if we look at on the right-hand side of the activation energy line, the area underneath the graph in the graph of B is smaller compared to the area underneath the graph of the graph of A. The graph of A is a graph of a higher concentration. Therefore, this indicates that at the higher concentration, there are more molecules with the energy that is sufficient for the molecules to collide effectively. And therefore, when the concentration is higher, the rate of reaction will be higher. Then lastly, the effect of the increase of surface area. When the surface area, by surface area, we're talking about the state of division of the substance, whether the substance is in tablet or is in powder form. So we regard the powder as the one with the higher surface area, and the tablets and the other forms as a smaller surface area. So now, if the substance has the larger surface area, in other words, is in powder, the state of division, there are more particles that are exposed per unit volume. If there are more particles exposed per unit volume, we expect more particles to have the correct orientation, or we expect more collisions per unit time. If there are more collisions per unit time, there will be more effective collisions per unit time, and hence the rate of reaction is going to increase. Let's answer first a few questions of the rates of reactions as we are running short of time. The rate of a chemical reaction can be expressed in, you need to be able to remember that the rate of reaction can be expressed in concentration, the change in concentration over time, the change in mass over the change in time, the change in moles over the change in time, the change in volume over the change in time. So let's look at this one. The first one says grams per mole. There's no time included there, so that cannot express the rate of reaction. The second one says energy consumed per mole. There's no time, so that cannot express the rate of reaction. And the third one, C, says volume of gas per unit time. So this expresses an amount of something per unit time, so that can express the rate of reaction. The last one, the moles of product formed per liter of solution. That cannot express the rate of reaction. The rate of reaction will be expressed in terms of time. Okay, we continue. The equation below represents the decomposition reaction of calcium carbonate. The subscripts here are very, very important. We see that calcium carbonate is in the solid form, calcium oxide solid, carbon dioxide gas. Which one of the following factors will increase the initial rate of decomposition? So when they say the initial rate of decomposition, they are talking about the rate of reaction. So let's look at the first option. The first option here is pressure. Will pressure affect or increase the rate of reaction of a solid? No. The pressure will increase the rate of reaction of a gas, not a solid. And then we look at temperature. Will temperature increase the rate of reaction with solids? Yes. Temperature affects the overall average kinetic energy of all the molecules, whether they are solid, liquid, or gas. Then we need to check the other option, concentration. Can you increase the concentration of a solid? No, you cannot increase the concentration of a solid. And therefore, we go to the last one. Is mass one of the factors which affect the rate of reaction? No, mass is not one of the factors which affect the rate of reaction. So the best answer in this regard will be B. B is the best answer in this regard. Learners, we are running in short of time. I'll ask that you screenshot this question as your homework, as you are going to take it and work on it alone. The answers will be provided. Screenshot this question, then you screenshot these are the answers.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful. Ubonge, lebuha, be grateful each and every single day of your life. Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence. Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ukubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school.
Welcome back, learners. As we were saying that this is your homework. You need to screenshot this question. We will also provide the answers. You're going to use this as you prepare for your exam. So you take a screenshot, then you take a screenshot of the next slide as well. So these are the answers after practicing. And then these are the notes for your chemical equilibrium. You take these notes as well. And then this will be our last slide. This is the multiple choice question that you will do, that you will answer as your homework. Thank you very much, learners, for attending. I hope this helps you a lot when it comes to your preparation for your final examination paper 2. Goodbye.